Talks is a huge success. It's being amazingly received by all of you. And I have received a lot of messages from kids and parents asking for, when is the next Plato talk. So really glad to know that, you children are enjoying how we bring in experts and, make them speak about the technology they work in, right? So we are going to arrange some more talks like this in the coming weeks as well. So please stay tuned. And today we are here with an amazing topic related to electric vehicles, and we have an awesome guest as well. And before we begin, so we have kids joined in a Zoom webinar, as well as the streaming session is being telecasted live in YouTube, so that students who didn't join the webinar can also look for this session in YouTube as well. And since it's a webinar session, you would be able to put your queries in the chat box and in your YouTube chat. So we will try to answer as many questions as possible in the limited time that we have, right? So first of all, in today's topic, we are going to invite our guest, Mr. Vignesh Reviraj from Ather Energy. So Ather Energy is actually a pioneer in the electric vehicle space. And if you have seen the news, so they are leading the EV space in bikes manufacturing, and it is being received very well. So I still remember the first electric bike that I got when I was in school, but I couldn't do much because it's quite slow and it was not durable, and we were not able to do a lot of things with AEV, right? While a lot of companies, import things from China and make electric vehicles, Ather Energy is purely an Indian company built and innovated by engineers from India, because normally we feel EVs and smart bikes are all science fiction stuff. But today it's a reality thanks to Ather Energy and the team. So we are quite excited to have Mr. Vignesh Reviraj, who is the product line manager at Ather Energy, who's going to share a few words about his journey and his expertise in the field of EVs. So we welcome you, Mr. Vignesh. Very good morning.
Yeah, thank you. Thank you, Asant, for the introduction. Good morning, everyone. Good morning, children. Yeah, it's
Right.
actually good to see a lot of people who have joined on a Sunday morning.
Right. Yeah, kids are super active. I think, they now I think they are looking forward for such kind of talks on Sunday so that they can get started with a super fun, inspirational event, right? And so building EVs in India, I think it's an uphill task, and your team has done an amazing job. So congratulations on that. Would like to know from you on depth about how your journey has been, and how is your current contribution towards EV space. So first, can we understand a little bit about your childhood, like what you have done and how you ended up in IIT?
Okay. Okay. So I actually studied in Bangalore in National Public School here. And from a very early age, I had an interest in science and technology. Right? It was something that fascinated me. And few things that I did there was actually robotics. Like robotics was the thing that actually got me into this. How can you get something to do everything that you are doing, like all the things that you don't want to do, that humankind doesn't want to do? How do you get a machine to do it? And that's what got me interested in robotics. And that was very interesting because that was a place where mechanical, electrical, software, everything comes together to get something that you want. Right? Now, as I got interested into that, then one way to go forward for me when I finished schooling was get into engineering, right? Which was where IIT came in. So gave the JE, got into that long back. I think joined IIT in 2010. Right? So it's been 12 years since I joined there. Took up electrical there because again my interest lied there. And yeah, in IIT, I just followed my love for hardware, like the whole joy of building things, the hardware that I was interested in. I just followed that there, went into computer architecture. Right. So computer architecture is actually how chips are made, like your processors. So how are processors made? What is the internal architecture of the processor? How are computer systems made? Right? Because that is the backbone of any man-machine interface in the future. So how are those being made? How are those being programmed to do what you want? Got into that, and then from there moved to, so when I completed my graduation, moved to Juniper Networks, which is US based MNC, right, which was doing computer chips for networking. So so to give an example, all the data that you consume as Airtel or Geo or whatever that a customer consumes, all of the data is driven through large data centers sitting somewhere, some even under the ocean, right? So the chips that drive that much amount of data, all of that actually is driven by is actually manufactured by Juniper Design and Manufacturing. So I was involved in that, and then from there moved on. Yeah.
Okay. Okay. Great. I think it's been a journey of a lot of innovation and interest. Preferring. I think
Yeah.
it's good to know that. And I think most of the kids here and the parents and teachers have joined already know about Ather, what they do, because it's quite famous today, right? So we would like to hear from you. Can you tell what Ather does actually, and what is your specific role in Ather Energy?
Okay. So so Ather was started 10 years back by two graduates from IIT Madras, basically Tarun and Swapnil. So when they started Ather Energy, they had a vision of a future where electric vehicles are the norm, right?
Right.
And that's coming to pass around the world. Now, at that point of time, they had to when they looked at what they needed to build, um, it was very clear that a lot of EVs existed. Okay. But
Right.
as you said, wasn't that the first EVs that you saw, the EV bikes that you saw were very low powered. They had zero reliability. They used to break down anytime. It wasn't
Right.
something that someone aspired to own, right?
Right.
So what Ather wanted to do at that time was to build an electric two-wheeler that someone would aspire to own. That is better than any two-wheeler out there. That is, zero compromise in us building it. And that's why we started building it from scratch. Every component, every part, the whole vehicle is built from scratch. Okay. And
Right.
that's how it's what it is today.
Yeah, although you sounded very simple, it's not really simple, right? Building some next generation technology in-house is something very difficult, right? I think Ather has done a very good job in that. Not only that, they also are in a very good space now, where a lot of people, when they think about buying electric vehicles, they go to the Ather Energy showroom first, right? So such a good thing to know. And we also want to know a little bit more in depth about electric vehicles. So if you can also explain, how electric vehicles work and how it is
Okay.
manufactured. Yeah.
Yeah, I will just share my screen to take
Yeah.
you through
Please.
a little bit of internals of the Ather EV itself, right? Uh,
Sure.
so, so if you actually see, so can everyone see my screen?
Yes. Yeah.
Yeah, so this is the EV that Ather makes, right? It's called Ather 450, 450X. So it's a electric scooter that we make. So we talk about the top level specifications as this one. So we are the fastest scooter out there, 0 to 40 in 3.3 seconds. Then when it comes to EVs, you have something called the range of EVs, right? Because it has a battery in it. So it's no longer it's not very similar to how you put fuel in the vehicle and a motor runs. Here you have a battery in it, which actually stores range that you charge, similar to how you charge your phone and things like that. And that battery has a particular range when fully charged. That's the kilometers that you can ride, right? So that is 105 kilometers true range. What we talk about true range is the fact that how long can you drive uh, in real life, right? It's not about testing. It's not about how someone says mileage is 20 kilometer per liter on something and you get 10. So that's why we call true range there. There's
Right.
something that Ather pioneered in this because we didn't want to confuse people with saying that, hey, our tested range is so much, but people get lesser. We wanted to give the real facts out there. Uh, the gradability, what you see is the slope that it can actually go. So 21 degrees is very high, it can go up the steepest of hills. You know. So why is gradability important? Like just this all just to tell you about why it is important and why did we care about these things when we built it. Right? So gradability. So if you actually see a lot of EVs out there, the earlier EVs, they will struggle up a slope, and you would see them people getting them off in during flyovers or ramps and then pushing them up, or with two people, one person has to get off and move. Like that is not what we want to build. Right? So 21 degrees is very high gradability, steepest of slopes, and we are also the first put out a touchscreen dashboard. So we have a 7-inch touchscreen dashboard with Bluetooth connectivity and 4G. Now, the reason we put in a touchscreen dashboard was to actually get, like, the future is going to be digital, right? You are going to be interacting with your vehicle like how you interact with your phones, your tablets, and all of that. And that is what we want to build. Like we want to build for the future. So that's why we put touchscreen dashboard with all interactions over there. Now, this is what you build, but actually, if you go into the internals of what it takes to do it, this is the philosophy that we followed. That is zero compromise on design, handling, performance, and user experience. So if you go to the internals, like what comes in. So when we talk about EVs, building an EV, it's actually for me, it's a culmination of everything I love, which is mechanics, electrical, and software coming together. Right. So that's something that you can see here. So this frame, this is called a frame. So this is a complete aluminum chassis. So this is the mechanical part of it. How do you build a skeleton of the vehicle that that is specifically meant for EVs, right? So that can accommodate a battery, a motor, and all of these things. Right? So how do you do that? So that is one part of the engineering that goes in. The second is how do you integrate your battery and motor and the powertrain into this? So the one in the center that you see is the battery, right? So that is a lithium ion battery. So you have different chemistries when you call about batteries. So that is a lithium ion battery. And the one on the right is a BLDC motor. So BLDC is nothing but a permanent magnet motor, right? So these are the main things. So you don't have an engine as such in your EV. It's actually your battery and the motor which is driving the whole vehicle. So this is just a top view of the same battery and motor, but you can see how it is fitted in such a way that when you build up a ground up design for an EV, you actually have a chance to rethink everything of how an EV needs to be built. And we were able to do that when we went back to the drawing board and achieve a perfect balance. Okay. There's a suspension that sits there, the brakes, and so coming to the heart of the vehicle, right, which is the most complicated piece that sits there, is the battery. Completely waterproof, so you don't have any problem driving it where you want. Everything capable of fast charging, all of these things. And this is the whole powertrain, which is your motor, your transmission, and it driving your wheels. So what it took to build this was how to build each of these things and how to get it together to work perfectly. And that was an engineering challenge with everyone who was a part of it. Actually, if you look at Ather Energy back when it started growing 7-8 years back, it was just a bunch of engineers coming together and trying to put this together. Okay, and it was put by and this was built by their joy of building, and that's why we call it built for us here.
Right.
Yeah, so I'd actually like to play one video on that. 1 minute.
Yeah, so while you do that, I think I still remember the one fact, children. So when I had my electric vehicle, generally electric vehicles, right, the motor is directly attached to the wheel, where it just rotates continuously, right? But whereas in Ather Energy, as Vignesh showed, right, so they have it separately and they have an actual mechanism to run it, like how any other bikes would do. So although it's a very simple thing for us to see, but a lot of innovation have gone through it. And as Mr. Vignesh told, their love for building things and their love for passion actually, made us to drive such an amazing EV vehicle. So yeah, Vignesh, please continue. Quite
Yeah.
excited.
Yeah. So actually, you would be very surprised by what it takes to build this, right? It is not about money. It's not about a large company coming together, putting their resources to build it. It's just about very interested people, like engineers coming together and building it. And this is a video that is about Ather Energy from 7 years back, right? I'll just play that, but you will see that it doesn't take a lot. It just takes passion. Yeah.
Yeah, pretty amazing. I even saw in the picture that, the room is so small that, I think the engineers itself, was sufficient in that room. And I can feel, how, your team has felt when they built the first EV, right? It's a proud moment, not only for you, I think it's proud moment for all of us in India when we build something in India for Indian people. So really glad to know that. And specific to you, I think now you are the product line manager at Ather. So how did you end up at this wonderful position? Like you said, you worked previously in an MNC, right?
Mm.
So for MNC too, and startup who's working on the next gen technology, right? How was that journey?
Okay. So, like I said before, I was designing chips in Juniper networks, right? Now, when I was doing that, I got more and more interested into understanding why, like in a sense, why these products are being built. Like, what is the reason these requirements exist, right? What are the customer requirements? So, like, customers are users. Like, what do they want, right? And then trying to fit into why are we building this product for them. So this is what we call in the industry right now, it is called product management, this particular role of figuring out what customers want and how do we build for that, right? So that is the whole profession of product management. It was not something common about 8 years back when I decided to move into that, but it's actually picking up very well now. So the industry for product management as a profession is actually growing very, very quickly. Right? So how I moved into this is I actually from there moved into a small startup, a 5-member startup who was trying to do a cycling solution, an IoT solution. So IoT is Internet of Things. Right? So it's again something that we were doing for cyclists to improve safety for cyclists. So things like we wanted to have brake detection, crash detection, and different safety features that we wanted to do through again hardware and software that would be work for cyclists. And we wanted to build that out of India, like again build hardware out of India. So I led a whole technology team there. That
Okay.
is from inception of the product to building the product to actually manufacturing it. Right. So that's what we did there. Then we got acquired by Ather. Right. So
Okay.
essentially, it took over the small company and all the people working there and the patents that we developed, there, technologies that we developed, everything Ather saw value in it and
Is
wanted
it
to.
working this? Okay. Sorry. Yeah.
Yeah.
Mm.
Yeah. So I moved into Ather and I moved in as a product line manager initially of the vehicle. So what are the features of the vehicle? How will we go about building it? Right.
Mhm.
And that was an enjoyable experience. And once we actually launched a couple of generations of the vehicle, I moved to the ecosystem. So before I talk about what the ecosystem is, I'll just give an idea of what is an ecosystem, right? Ecosystem of products.
Right.
So when we are looking at transforming an industry like mobility, like how they essentially your commute, right? Driving a two-wheeler to go from point A to point B. So far, it has always been about the product, the scooter that you have, right? When we move to electric vehicles, it's not just that. It is about looking at the whole infrastructure and everything that needs to come up to make this transition happen. How do you move from petrol vehicles, which have a very different refueling behavior? You go to a petrol pump, you fill fuel, and you drive, to something that needs to be charged every day, right? To drive the vehicle. So how do you create the charging infrastructure, which is essential for EV adoption to happen? So that is the major part of the ecosystem, and we don't want to do it exactly like how petrol pumps are today, right? Why do you need to go to a petrol pump to fill fuel, right? If you could get fuel at home, why not do that, right? So that is what we look at the ecosystem for. So now I look at the ecosystem. So it's both first the vehicle, then the charging infrastructure mainly.
Okay. Okay. Good.
Yeah.
And also, it's really nice of you to, how was this shift? Personally, I want to know, like, you were in US working at an MSc, right? And then you joined a 5 people team, right? But what I felt is that, your passion for innovation, your passion towards, why we have to do this, right? I think, we at Plato Labs also have on the similar thought, on the classes that we do, right? Before we go ahead about how to do it or what to do, right? First we need to understand why, right? So what's the problem that we are solving, right? So why we need to build this project now, right? What kind of a problem it will solve, right? So understanding the why part will actually drive the entire journey that you take next. So really glad to get to know about this from you. And I see you using the word robotics, IoT a lot, which is actually an innovative technology by itself, right? So super glad to know that. And so now coming to Ather again, like how does this entire so we have seen the first bike that is manufactured. So now how is it being manufactured today, right? And that is something that I think kids would love to see as well.
Yeah, I can just show the manufacturing of it. Just,
Yeah,
yeah,
thanks.
one moment. Just a minute.
Yeah, sure.
Yeah. So we have a factory in Hosur, Tamil Nadu, where we actually manufacture this. We have a capacity of about 4 lakhs per annum, which is approximately 30,000 a month, right? And this is a great video which just shows how we do it.
Right. So from one vehicle to 1,000 vehicles per day, I think it's been an amazing journey.
Yeah.
Right, right. So it was really interesting to see that how bikes are being mass produced, right? And how and I still I see news that there are a lot of waiting time for the Ather bikes to get. So that such is the demand that it's grown, and the popularity of Ather. So really nice to see that such kind of things are happening right now, right? So. Children, I think this is what great exposure does. So, for example, Mr. Vignesh, he got that exposure into robotics at his early age, and then he understood how to build hardware, and he loved his way that he's actually building things, right? And when he's building those hardwares, right? So he had this question, why I'm doing this, right? So that made him to shift his role from there to a startup where they were building the ecosystem for electric vehicles, and later on here we are where he is one of the amazing team member of Ather Energy, who is actually transforming the way we see electric vehicles today, right? So in fact we at Playto Labs also provide such kind of opportunities for kids to think why they are doing these projects and why they have to learn specific concepts and how it will be useful. And such kind of talks are also an example of how we are trying to create exposure for kids towards the technology that's in the upcoming future, right? So thanks for taking time and also helping us with your expertise on the EV space. So Mr. Vignesh, I want to ask you one thing, like, what is the, biggest challenge that, EVs face today? Because I can see a lot of questions from kids as well, which is revolving around, like what are the major concerns or what are the, biggest problem that we, face in EV space? If you can throw some light on it, it would be helpful.
Okay. So, see, there are two big challenges when it comes to EVs. Okay. One is everything around the battery. By everything around the battery, I mean, today we use something called lithium ion, right? So that is very expensive today. And that also needs to be, when you're designing a battery around lithium ion cells, you need to actually build it in a really safe way, right? It has to take a lot of safety, a lot of durability into concerns, because if that is not taken in at the time of design and testing, you will actually see a lot of what would you call EV fires on the field, right?
Right.
So around the battery, there will be a lot of innovation that will happen in the future. How do you actually get the cost of the battery down? How do you get it to become more and more safe, right? So that the transition to EVs can happen safely, right? So that is one big challenge. The second big challenge, I think someone wrote it here. Who is Vikramajit? Right?
Mhm,
You have to
mhm,
establish a big ecosystem. That
mhm,
is right.
mhm,
That you have to, like today, your charging infrastructure doesn't exist. You know, and that ecosystem has to be established. It's a chicken and egg problem. Will the infrastructure come first or will EVs come first? Right? And you have to solve it. You have to get the infrastructure in first. Adoption is not going to happen till the infrastructure comes up. So a
Right.
lot of investments into infrastructure, into the charging infrastructure is required, and that ecosystem needs to come up. So that is the second biggest challenge. Actually, Ather is doing a lot in the second place also. We have something called the Ather Grid, which is the public charging stations for EV two-wheelers. And we have already around 1,300 in the country, which is the largest in the country today. And we will be at around 3,000, 4,000 by the end of the year.
Okay.
So, so these are the two things that needs to come up: the infrastructure and the batteries.
Okay,
Yeah.
got it, got it. And I think, in lines with the same question, few kids were asking, there were, news about, electric vehicles, getting fired, right? Or, they're getting caught in fire, right? And but we hardly heard any news about it with respect to Ather Energy, right?
Mm.
So what is the, major cause for this? How is, Ather avoiding it? Is it because the everything is made in India and we are not importing the parts from China and other countries? That is the reason, or what is the reason? Can you throw some light on that as well?
Okay, actually, with this, before I go into the reason, I actually have a very 1 minute.
Mm-hmm.
Yeah, I will just again play a video. Okay, and this video is actually from one of, it's the head of battery design at Ather.
Okay. Mm-hmm.
And that would, I did not expect to play this, but just take a look. So this is Shreyas. He is from he heads the battery design team at Ather
Okay.
Energy. Yeah.
This is Shreyas Sidapati. Right now, he's eating his favorite ice cream. When he's not, he's designing battery packs at Ather Energy. Batteries that can take you from 0 to 40 kilometers per hour in 3.3 seconds. Batteries that can offer consistent range. Batteries that can work in the monsoon, winter, wind, sandstorm, and yes, summers. How could we forget that one? Shreyas knows the true limits of the batteries he's designed. So he isn't making any tall claims. What he's confident of, though, is that they're really safe for most Indian weather conditions. So confident that he's willing to sit on a lithium-ion battery pack, which has been baking at a high temperature for the last 3 hours, eating his favorite ice cream, the summer bliss.
Very nice video.
Yeah, so this is just a fun thing that we did to actually
Mhm,
showcase what we do. But
mhm,
why did we do this, right? Why are we
mhm,
able to say this?
mhm,
Because we took 5 years to engineer our battery.
mhm,
Okay, 5 years of engineering, 5 years of testing.
mhm,
So the way that we go about this is the whole battery is engineered in-house, and there are a lot of testing that is done in it.
mhm,
Some of the testing that you see, you'd have seen in the video. We actually put it in a high temperature chamber and bake the battery, like how we cook a cake,
mhm.
and
Right.
then see that nothing happens to it.
Mhm.
We drive nails into the battery. Like we actually sit and hammer nails into the battery and see if things happens to it, right? So that is the level of testing that we do. Uh,
Okay.
okay.
Mm,
So
mm,
yeah, and the fires that you see is because a lot of people cut corners in this, take it from really cheap, engineering and all of that from China, imported from China, and low quality, low cost, and stuff like that.
mm,
We did not want to take a risk with that. It's all about the engineering that goes behind it.
Right, right. Got it, got it. I think, that is an interesting answer. I think, I think the answer is in the, entire discussion itself, where how, when passionate engineers come together and they build something out of, their own hands, right? They tend to make it, safer and smarter for others as well, right? So, yeah, before I begin, I think there are a lot of questions pouring up. I'll just quickly take some of the questions which is, which we haven't covered still. So there is one, there's actually a question from, students like Aryan Singh and Anirudh Das, who asked, will you be using robots to assemble the scooters anytime soon?
So we actually we have two assembly lines, right?
Mm-hmm.
One is that of the battery.
Mm-hmm.
So okay, since this question came, I will just show that part in that particular video.
Mm-hmm.
1 minute. Okay. So okay. So if you see this. You see, see, yeah, can you see this? This particular section, that is our battery manufacturing. Okay, so all of these are robots. Like what you see around, everything is robots. Like none of this is manual. So the whole battery manufacturing line has no manual intervention. It is all robots that are doing this. You will see the robots in action as pick and place. Yeah. So
Got
I
it.
think there are a lot of questions on robotics here, right? And robotics is everywhere. So one thing what you saw is the whole automated assembly for the battery. In when it comes to our vehicle assembly, we have a mix of both.
Mm-hmm.
There are it's a whole conveyor belt. Some
Mm-hmm.
stations are completely automatic, some are manual. So that's a mix of the two that we have. And the future, like if you actually look at our factory back in 2018 to now 5 years later, a lot more automation, a lot more robotics have come in. And as we move towards the next 2 years, it will keep increasing. Like more and more stations, as we call it in the whole assembly journey, will become automated.
Right, right. We are seeing that already, and I think a lot of innovation is going to happen everywhere with respect to how we use, robots and IoT into the process, right? And here is also an interesting question from, a student who has joined us in YouTube. So he asked us, how is Ather taking care of the environment with respect to worn out batteries? How are these batteries disposed? That is his question.
Okay. So when it comes to, so lithium ion batteries have a life, right? They have a life of normal usage around 5 to 8 years, right? Based on how it is made. So one thing is usually these batteries have a life around 3 to 5 years. Ather batteries generally have a life of about 8 years. Like our batteries have been in the field for the last 5 years, and we have got zero batteries that have fallen below 70-80% of their capacity, as you call it. So it's not degraded as bad as we have seen, and it's mainly due to the testing and design that has gone into it.
Mhm.
So we expect batteries to start coming in approximately 3 to 4 years down the line for us. Okay.
Okay.
So we have a lot of plans on what we will do with taking care of the batteries. None of it has actually been put into motion because it's not necessary at this moment. But when you talk about what happens when it comes to environment, there are two things that we will do, right? The first one is called the second life of the battery. So we have a lot, we actually have a few installations where we have done, where the batteries are used as inverter batteries. So in
Okay.
homes, you have inverters, right?
Right.
And you actually have a lead acid battery there. So why can't you use our battery after they've been used in the vehicle? Why can't you use it as inverter batteries? So we have few installations that we have done that way. The second way of doing that, which we'll do, is recycling. So actually send the cells to the recycling plant to extract lithium and other metals from it and create new batteries. So these are the two ways that we will take care of it.
Okay, got it. Got it. Interesting, right? And there's also a question from actually students who join in Zoom as well as in YouTube, right? What is an alternative to lithium-ion battery?
So there are a lot of alternatives being explored today.
Mhm.
Uh, Most of them are in the research stage, not yet commercialized. But I'm sure in the next 5 years, a lot of this will be commercialized, right? And this is very interesting. Actually, a lot of people, or a lot of you people, when you actually hit college and enter into jobs and all of that, there will be a lot of innovations happening around the battery. Like that is a given today. So we have something in exploration. There's something called a solid state battery that is being explored. There is something called graphene batteries, right?
Mhm.
All of these are still in the exploration stage. In lithium, in whole lithium-ion batteries itself, there is also something called the lithium LFP, lithium iron phosphate batteries that is there. Those are what a lot of cars, especially a lot of cars have started using. Right? Now, those batteries are generally bigger. By bigger, I mean for the same capacity, they are much bigger in size and weight. But the advantage that they have is they last longer and they are much safer. So that is one innovation that has happened, but more innovations are expected in the future.
Okay, okay. So kids have this, very interesting questions. So there is one child, Mahaswin. So his question is, sir, is there a way we can, increase the mileage by making the bike produce electricity and use electricity while it is running?
Hmm.
So,
So I'm going to assume produce electricity. Okay.
hmm,
So first thing is there is something called regenerative braking.
okay,
So regenerative braking is nothing but when you press the brakes, there is a lot of power lost, right? Now, some of that power, because your motor is coming from a very high RPM to standstill, some of the power can be driven back into the battery as energy. So that is called regenerative braking. And Ather has it, a lot of EVs have it today, right? So that is not all power when you brake is lost. Okay. So that is one way of generating some amount of power which is lost that comes in that it can improve range. The second one, I'm assuming the question is, can you generate through solar or something like that?
so I think the more question was like when the bike is running, so it should produce electricity and use the same electricity to, increase the mileage of the, so it's like recharging itself.
Yeah, so that's what the recharging is the regenerative braking that happens.
Mhm.
Otherwise, while running, if you're trying to produce electricity like how a car produces electricity through alternator,
Mhm.
uh, that is not feasible because you always have efficiency losses. So you will always burn more energy trying to produce lesser amount of energy. That's because of efficiency losses that come in. Yeah.
Okay, okay, got it, got it. And there are a lot of questions pouring up. I think this one question is that is Ather going to make a four-wheeler or three-wheeler in future? Do Ather have a plan for it? A question from Kavish, who's joined us in YouTube.
See, the way we do things, right? That is, we go into the fundamentals, break it down, and build everything from scratch. Right? That is the way we do things. We have done it for a two-wheeler scooter. We will do it for a lot more two-wheelers. Four-wheelers is something that is slightly far into the future, because to do the same in four-wheelers requires a lot of investments to come in. A lot of money, a lot of investments needs to be put in. Much like 10x of what it is required to build a scooter, right? So it's something that we will do once we have established great scooters out in the market.
Okay, that's really interesting. I see a lot of passion, from you towards EV. So I want to ask you, how do you think the future is going to be? Will EVs play a very important role in the future, or how will the future filled with EVs look like? Can you throw some light on that?
Okay. See, today there are about, how would you look at it? About 200 lakh vehicles on the road total, right? Now, with all projections, with everything, that in another 7 years, that is by 2030, about 100 lakhs of them. Sorry, there are about not 200 lakhs. There is 200 million. So that's approximately 20 crore vehicles on the road today. Okay. Now, all 20 crores of them will become electric, like it's a given, will become electric sometime in the next 15 years. Now, by 2030, what is expected is that you will have about 10 crore EVs out there, of which 90% of that, which is 9 crores of them, will be your two-wheelers. Okay. So that is a very clear projection that we see. And yeah, that is what excites us, because we are at about like less than 1 crore of vehicles today. We are actually less than, not on 1 crore. We have 10 lakhs of EVs on the road today. Now 10 lakhs to 200 lakhs is what drives us.
Okay, great. And so I think, nowadays we are seeing a lot of, companies when they want to showcase their next innovation, right? They launch their EVs, right? Either it be it a bus or a car or autos, right? So do you think the future, will be completely driven by EVs, or will there be any challenges when we do that?
See, every projection today from around the globe, right, is that everything will be driven by EVs. Okay, electric vehicle is the future, will be driven by that. And see, there are a lot of reasons as to why. Okay, I have but that is everyone's principles driving it. Now, my reason why is that, see, your transportation today is driven by fossil fuels, right? Fossil fuels is limited. It is not unlimited form of energy. So fundamentally, human civilization cannot progress if transportation, which is the backbone of civilization, is being driven by fossil fuels, like a limited form of energy. It has to move unlimited. Now, the way the world is generating more and more unlimited forms of energy is through renewable sources of electricity. Like you have solar, you have wind, you have all of that coming up, and that generates electricity. So if you move transportation to using this electricity, right, that is when essentially transportation industry can grow. Human civilization can grow. So that's why I believe that it will become electric in the future. It's a very philosophical answer.
Right. I get it. I mean, we all sit here, and so yesterday I saw a picture, right? So people who lived at 1900, right? They were asked a question: how will the world at 2000 look like, right? So there was a picture where they made these balloons, right, which is attached to humans, and the people are walking on water, right? So with the help of balloons, right? So but that is far from what happened in the reality. But today, I think since we are becoming pioneers in technology, we are able to, I would say, accurately predict, how the world is going to be, 5 years from now, 10 years from now. So I'm sure that, we would get there, and we would actually have a very, sustainable environment as well, right? So that's a lot of, facts about how the future is going to be on EVs, right? And so from your answer and the videos I have seen, so EVs involve not only mechanics, but it also involves a lot of electronic systems, a lot of programming into it, right? Embedded systems. I think what not all technologies are integrated into it, right? So there is also a lot of questions around the children, like if someone is interested in this, right? How can they develop a career in EVs, right? What is the journey that they have to take? That's a
Right.
question.
Okay. Now, see, there are different career paths. I'll talk a little bit about what got me interested in general, right? Um, so I spoke a lot about me getting interested in science and technology early on. And one of the things was, I don't know if a lot of people have heard of this FLL robotics competition. Right? It's something that happens every year at a global level. Um, and like, because I was interested in it, I actually started using the Lego kits to build robots back when I was in 8th standard, almost the same age as all of you guys here, right? Built that and was actually sponsored by India to go to US as part of the Indian team and actually build robots to cross certain obstacles, do certain things. And that is what got me interested into science and technology, the robotics piece of it and everything. So the first thing is building engineering fundamentals, right? Building. Like it's not just about learning, it's not just about reading. It is about building. Get something, get some robotics kit, get some kit, build it. And as you build it, you will be more and more curious about what it takes to do it. How do you build it? How do you go about it? And you will end up learning more and more about it. And just build those fundamentals of how hardware, software, mechanicals, all of these work together. And once you build that, then you can do anything in EVs. You can actually do anything in technology. Right? It's all the fundamentals that needs to be strong, fundamentals that needs to be built, and a passion for building.
Right. And since it is a multidisciplinary field, as you told, robotics is something that involves all of them, right? From mechanics to electronics to programming. And as kids here, right, a lot of kids here, Plato students who also, build projects in their classes and understand technology in an innovative way, right? So, as stretched out question to this, right? So what kind of, jobs would exist in future in the AV segment?
So you will have actually you will have everything, right? You will have everything starting from design to engineering of mechanical, electrical. This one you will have defining requirements. Then you will have manufacturing that would be there, and then you'll have business, right? So all of these things would come in the future, and none of that would change significantly. What we expect happening is a lot of these things would get automated, especially in the manufacturing side. But otherwise, it's going to be pure again, like basic technology fundamentals are clear, and everything is going to be built on that, even in EVs.
Right. That's really interesting. And as your earlier answer stated that, it's going to be multidisciplinary and the future is going to be filled with EVs and, there are a lot of opportunities coming up, right? And as we got to know that, how you developed interest by, building robotics projects during your school, right? Basically, you went out of your syllabus, right, and studied something, apart from what is there in the school curriculum, right? And that made you develop the interest towards building things and also having this philosophical mind of why comes first and then the how and the what, right? So I think that really is very inspiring. Thanks for giving us such an inspirational speech about how your journey have been, right? And I think to an earlier question that I asked, right? Coming from an MNC to because you graduated from IIT Kanpur, right? And then you joined an MNC for a short period of time, and then you joined Ather, right? I think it's a very important decision that you have taken, towards building a sustainable future, right? So, like, how do you see that? What is that? What is an advice that you would give for us, right? On how we have to move forward.
Yeah. Okay. See, the decision to shift for me from an MNC to an early stage startup, right? It was not easy because it came with a lot of risks. Um, like in MNCs, you make good money. Move to a startup, I don't make any money anymore, right? So that was a it was not an easy decision to make. But what I want to actually leave you all with is follow your passion, right? And this is not in terms of just a line that everyone says. Think of it like this. You are going to be graduating college at around 21, 20, 21, and all of that. And that is like you have a 40-year-old career on average in front of you, right? Which is till 60. Now, what decisions, the risks that you take in the beginning actually put down a lot of these parts for you in the future. So figure out what you want to do. Figure out if your thing is joy of building, go build something, right? And that is my advice to you. Just learn the fundamentals really well and go follow your passion. And it's a long career that everyone has. Don't view it as a very short-term thing that I need to become this at 25, this at 30, this at 40, and things like that. It's a lifelong goal that you need to have.
Right. I think, that's really a wonderful, suggestion, Vignesh. So even our goal is here to, help more and more kids to get the same kind of exposure that you have got, right? Because, we are lucky today because we are seeing a lot of, advancements in technology, right? And even at Playto Labs, we get to see a lot of amazing ideas and creative projects that, students build in our classes every day, right? I mean, we keep hearing about how Elon Musk is transferring EV space and his work towards sustainable future, right? But now we are seeing people, like you, who also work super hard to make, all of us at India proud in, building the next gen technology to have a sustainable future, right? So I think it's going to be more common in future where, kids get such kind of, amazing experience from platforms. As you told, they can get a kit and get started, right? So, like us, there are a lot of opportunities that are available for kids today, where they can actually, get started with building projects and, become the future innovators. So thanks a lot for your time and, taking your time today and inspiring us and the kids who are watching this talk. So we wish you all the very best for you and your team, right? So just there are a lot of questions. If we can just have quickly take last few questions, I think that would also happily that would also make kids enjoy a lot, right? So so there is one question from Arush, like how many batteries are there in one vehicle, scooter?
One battery. It has a lot of cells. It has approximately 1,000 cells in a single battery, but it's one battery.
Okay. So that's also an interesting question. It is possible to make self-driving AI-powered scooters.
Oh, it is. It is. There are a lot of things that needs to be figured out, like self-balancing, and the whole self-driving bit of it. But in the future, 10 years down the line, yeah, it definitely will come up.
Okay, got it. And there's also a question from Inav, Gogolapati, where he asked, will Ether ever make an off-road EV?
Make an off-road EV.
Mhm.
Yeah, we will.
Okay.
I can't say anything more. But
Right. I think, I understand, right? And uh, yeah, so another question that we have is, so what do you need to study to get into EV batteries design? That is a question from Alia Sagar.
So for EV battery design, there are in your basic, it's obviously science, but as you go into college, you can either take up mechanical. That's one thing. You can mechanical or electrical. So these are the two things that are fundamental courses for battery design. And in that, also having a deeper understanding of thermodynamics.
Mhm.
Right?
Okay.
Yeah. And in the future, if you have to go for specializations, it will be a lot on materials, right? Like nanotechnology, materials, graphene materials. Like I said, the newer batteries are going to be about all of these things. So it is about materials.
Okay, okay. Got it, got it. And mostly others are more of the multidisciplinary field. I think, getting started is the key, as you told, right? And you just figure it out as you move along, right? Okay, great. I think, we have covered most of the questions here, and, a lot of students here also will be having their classes in some time. So it's really, wonderful meeting you, Mr. Vignesh. It was really inspirational to, know from you. So thanks a lot for taking your time today.
Thank you. So thanks everyone for joining also. It's actually good to see a lot of these questions, right?
Mm.
Yeah, it's nice.
Right. I mean, there is one question from Kanav who've been asking, like, what's the meaning of Ather? Why the name Ather? So is
So,
there a, explanation for it? Yeah.
like I talked a little bit about energy, right? That we actually want to move towards a place where, at least for human civilization, there is infinite energy. And I also saw a lot of questions about infinite energy. It's not the way that infinite energy is looked at from a physics term. This is more from a human scale term, right? That you are able to harness the energy of the sun, the natural things around you, and actually create energy from that. It's not infinite energy in terms of the physics part of it. So when we wanted to look at that, so Aether is a mythological material that actually exists around the universe that fills the space between everything. Right? The dark matter, as you call it, or something like that. It's that. So it's drawn from that mythology that there is some dark matter, some energy that fills all the space between the universe. That was the inspiration for it.
Oh, nice, nice. I think, we are also ending the talk with a very interesting thought. I'm sure that the kids would now go and do a Google about Aether, understand the meaning of it. Oh, so really nice of you, Mr. Vignesh. Yeah. Thank you so much for joining. Yeah. You have anything to say, ask for the kids?
No, nothing else. Go build, like just go build with your hands.
Mhm.
Yeah.
Okay, okay. Okay, kids, I think, it was an amazing session from Mr. Vignesh today. So, kids, please do, subscribe to our YouTube channel so that, you get more updates regarding our future Plato talks as well, right? And you can also get to see experts in the field today, and then you can also interact with them and also learn how the, upcoming technology is, right? So until we meet in the next Plato talk. So it is bye bye from our side at Plato Labs. So please do like, comment, and share our video so that a lot of kids like you can also get benefited. Yeah. So thanks, Mr. Vignesh. Have a wonderful day. Have a wonderful